Hi everyone, in today's chapter 7, we'll be looking at quantitative research designs, and there are three types of designs that today. The first kind will be the classical experiments, and the classical experiments will talk about a little bit more the tradition and the history that it has evolved and how it's used in social science research in communication. The second time we'll be looking at quasi-experimental types or forms, and lastly we'll look at descriptive studies or descriptive forms. But here we have a table that helps us summarize these three forms of experiments or quantitative research designs. The first type that we look at the classical experimental form. The key thing is that the researcher controls the manipulation of the independent variables. So that is key. And one key thing why researchers who do quantitative research, why they like the classical experiment, is because we can control, the researcher gets to control the elements and the environment as much as possible. And why is that important? It is important because when the researcher can control as many possible variations in the environment, in the independent variables, then any kind of effect, if it's statistically significant, the researcher can then say it is because of the independent variable. Meaning to say everything is held constant, everything is controlled, every possible element, every possible characteristic that they can think of is controlled, then the statistically significant change in the dependent variable is because of the manipulation. And when we say manipulation, we mean the change, what has been altered in the independent variable. We'll go into more detail about what the manipulation and independent variables are in later slides. Random assignments of participants are also present in the classical experiment design, and that's key. Why? Because when we have randomly assigned samples, it tells us that each individual or each element within the sample has equal chance to be in the treatment group or the control group. Again, what are treatment group and what control group? We'll look at it in the next few slides. Next, we'll be looking at quasi-experimental designs. So researchers, although they like the classical experiment design, they also realize that there are some downsides to it, mainly because it is not in the natural environment where the participants or the sample reside in. And so that takes away some of the realities that the participants might be experiencing, and that affects generalizability to some extent. And so one way to fix that, or one way to address that limitation, is to use a quasi-experimental design. So again, the researchers have more or less some control over the independent variable, but not as much as in the classical design. Researchers, when they have any change in the manipulation of independent variables in quasi-experimental designs, it is mostly because of natural variation. And we'll look at natural variation, what that means in the section in this chapter. Another thing that is distinct between the quasi-experimental design and the classical experimental design is that the random assignment of participants is not present, meaning to say there is no random assignment. People do not have equal chance to be in the treatment or the control groups. Finally, the most least control that a researcher will have, but probably practically speaking the most useful or most used design would be the descriptive design. The manipulation of IV is absent, and so that is not very good, and the random assignment of participants is also absent. With the absence of these two important elements or characteristics of quantitative design, it has less power in demonstrating that any change in the dependent variable is specifically because of the independent variable. But as we said, practically speaking, it is the most common used reason because, or one of the more commonly used quantitative designs, reason because of access and because of it being one of the easier ways for researchers to use in terms of quantitative designs. So with that summary, let's jump into the classical design and see what that is. Or actually before that, we will look at some general characteristics that are equal or present in all of these quantitative designs. So that's the next step that will be. Okay, so the experimental design generally, why is it so useful is because it helps us to determine causation. So meaning to say we are interested, for quantitative researchers, we're interested in cause and effect relationships. So the presence of A affects B. Is there some kind of difference? Meaning to say, if A is present, that leads to an outcome of B, then in different situations, are any differences significant because of the presence or absence of the independent variable? So experiments are very helpful, very powerful in helping us determine causation, cause and effect relationships. The classical experimental design especially is conducted in laboratories and in controlled simulated settings. So as we mentioned earlier in the previous slide, those experiments, they happen in very controlled setting. That means to say that it is an environment that the researcher has control of course, and they design how it looks like, basically. So it can be a very simple room where there are no windows, or maybe say the room has not a lot of decoration. It's very simple, very bland. It just has things that the researchers need in order to execute the experiments. So it's very removed from reality, it's very different. So imagine if we were to study how people communicate with their parents. It'll be probably more natural to study that in places where individuals and their parents usually communicate or hang out. So maybe say the living room of their house, or maybe say their favorite park or a favorite restaurant, for example. So those places will be the natural settings of those individuals who hang out, and we will be able to study their communication patterns and topics more closely, more accurately in those settings than as to compare. Say we ask the individual to bring their parents to the laboratory, and the laboratory basically is just a simple square room that has not a lot of decoration or probably no decoration, and then we ask them, okay, start talking. We would like to see what you talk about and your communication pattern. So we know that that is not going to be very effective. However, we like laboratory settings or the lab environment, reason because we can control extraneous influences. That means to say things that can affect, things that can influence or have an impact on the phenomenon that we want to study. Then we want to extract it, we want to remove that, so that when those possible distractions are removed, then any impact on the dependent variable we can then attribute to the independent variable. So that's why experimental designs, although it is very sterile, although it's very can be very artificial, but because of the extreme control researchers have in that environment and setting, it is seen as a strength as well. So when a researcher uses the classical experimental design, when we control the independent variable, we also want to make sure that we do something called a manipulation check. So what is a manipulation check? The manipulation check is a way to verify, the researchers would use it to verify that the independent variable that's manipulated is actually effective on the participant. All right, it is effective on the participant. So for instance, we may say, let's say in an experimental design, at the start of the experiment, participants were given a set of instructions, maybe on a piece of paper or maybe a few pieces of paper. Somewhere along the line in the process, one of the pages there's a funny picture, and then or maybe there's a really funny joke. Okay, and then the researcher asked on that page saying, rate the funniness, rate how funny the joke was. Okay, so if the joke was really funny, we'll probably be safe to assume that the participant will rate the joke as relatively high, so pretty funny. So those are one way that we can do manipulation check, is to make sure that the independent variable is being tested, is effective, and the participant is influenced by that effectiveness of that manipulation. Other ways that people might have done, I've heard of an experiment where perhaps in a study that there is an unusual instruction. There's an unusual, unexpected instruction, and then they want to see if the participant would ask the administrator or the research assistant, what does this mean, or what does this statement mean, or I don't understand, I don't know how to respond. So if that were to happen, then we know that the participants actually read the instructions carefully, and then we know that because they read the instructions carefully, the responses that they're going to give in the experiment will most likely be accurate and effective for us, or useful for us, instead useful for us to use in verifying the effect, if there is any, of the independent variable on the dependent variable. So researchers have a lot of control in classical experiments, experimental design. We get to select the treatment and control groups. So we alluded to that earlier, but so what are treatment and control groups? Treatment and control groups. So it's easier to talk about control group first, then we talk about treatment. So the control group is the group where it is held constant. It is held constant, and we are using that to compare to the treatment group. So basically, we have at least, in the most basic design, there are one control group and one treatment group. So you have two groups. We're effectively trying to control, so we're effectively comparing the outcomes of the control group with the treatment group. So, for instance, we might have an experiment that studies the effectiveness of a new drug or a new medication. So, when participants are placed into the control and treatment groups, and it should be randomly assigned, the control group might receive the present treatment. So what is the most common, or the standard treatment that participants or people who suffer from this disease get? Okay, so whatever it is, say fever. Okay, so fever, maybe what's the best medication to treat fever? So the standard treatment that people receive to help with their fever or their illness, that will be the control group. They receive the same treatment, the standard treatment, the standard medication. Everything is standard, is the same. On the other hand, people who are placed in the treatment group, however, receives the experimental drug. So this medication will be, or the experimental drug will be the drug that the researchers are trying to test to see if it's effective, and to see if it is effective, then to what extent is more effective than the standard treatment. So that way we can control the environment, we control what participants in the control group receives, which is a standard treatment, and then people in the treatment group receive the experimental treatment, which is the new drug that the researchers are testing. So those differences that they receive for these two groups is not just whatever we like. Just because there's a difference doesn't mean that it is classical design that is based on treatment and control elements. More importantly, the selection of participants in treatment and control groups, the difference in the independent variable must be based on some kind of theoretical foundation. It has some theoretical purpose to it. meaning to say that it's based on some theory that has been around. Based on that theory, the researchers want to test if that experimental or novel medication will actually be effective. So it must be based on some theory, and it's not because, or just because there's some difference, we think that that's fine. No, it has to have some theoretical reason to be used in, to be consistent with the scientific tradition of using classical experiments. We talked about random sample earlier. So random samples are important reason because we want to have the participants to be randomly assigned to the control and treatment groups, and that every participant has an equal chance to be assigned to either of those two groups. Meaning to say, when we get our randomly assigned treatment and control groups, the participants in each of these two groups, their characteristics are more or less very similar. So there's very little difference between the two groups. So there we have the random assignment participants to each of the conditions, and when we say conditions here, we're talking about the treatment and control groups. So if the treatment group gets a different manipulation and different drug, the experimental design, then that is the condition that we're talking about. And here we have ensuring participants in each condition, so treatment and control are equivalent before any treatment. As we said, if the two groups or the two groups are randomly assigned, participants are randomly assigned to either of those two groups, then the changes or the differences between the two groups should be very slight, or they should be very similar. Okay. Manipulation checks, we talked about that in the last slide. So here we have an example of how an classical design can look like. So here we have, over here on the left, we have participants, or all the people that we have selected to be our participants. They're all right here. And the next step in this example, we ask them to define their drinking behavior. How much do they drink, whether they are binge drinkers, moderate, or they do not drink. So we ask our participants who are right here to self-disclose their drinking behavior, whether they belong to this or this category. So after we have our participants telling us what their drinking behaviors are, and we have allocated them into these respective three categories, then based on random assignment, so meaning to say people in this category, everyone has an equal chance to be in this manipulation or this manipulation or this manipulation. Based on some random assignment, we allocate each individual in each of these three categories into one of these three conditions right here in the middle. Okay, so meaning to say, some people who are binge drinkers, some of them will come here, they will receive this condition. Some of them will come to here, they will receive this condition, and some of these people, these binge drinkers, they'll be allocated to this condition. Okay, so after we have done that, after the participants on each of these categories, they have been allocated to each of these conditions, we then ask them what kind of response or what is the outcome of that condition. So we can imagine that some of these individuals who are here in this first condition, they would respond this way, or they might respond this way. Similarly, people in the second condition, they might respond this way, or they might respond this way. Same thing for people in this category. Okay, so when we say a post-test design, post-test only design, we mean that a survey is administered at this point right here. Okay, this space right here, after we have gone through the condition, after the participants have received the condition, we administer a survey at this point to see how they are responding based on the condition that they received. And then based on the outcomes, which is outcome 1 or outcome 2 right here, we can then backtrack and see if which of these conditions are more effective to arrive at one of these outcomes, and depending on what their drinking behaviors are of our participants, which of these conditions are most effective to get them to one of these two outcomes that we want to understand. So that is a post-test design, pretty effective, pretty fun, have people assigned to different groups and based on their self-disclosed characteristics or criteria, and then we random assign them to conditions, and based on conditions administer a test or a questionnaire, and then see what the outcome is based on the condition that administered. So that's the post-test design. It is effective, it's easy to administer, but the downside is we only know how they react after the condition has been administered. We don't know what their behaviors and attitudes were prior to the condition. So how do we fix that? Well, one way to do that is this figure right here. This is kind of like of a longitudinal design because we are capturing another set of data 2 weeks after. Typically, longitudinal designs, we take multiple measurements over a long period of time. So it could be a number of months, maybe a number of years, depending, maybe it's a big study, number of years, but usually maybe a number of weeks or number of months. So if you're taking multiple measurements over a period of time, then that will design. Okay, so there's a time lapse between each of those measurements. Again, it helps us to determine the effectiveness of the condition that was administered. We are seeing how long-term the effect is, if there is any long-term effect. So one of the strengths of experimental designs, the strength of a classical design is that researchers can manipulate the independent variable and then see if there's any effect or change on the dependent variable. If there is, because of the high amount of control researchers have, they can then safely and confidently say it's because of independent variable. But of course, that is dependent if there is a statistically significant finding. So here we have, as explained previously in this second dot point, is the precision. Because of the control of the environment, researcher can control almost every possible condition, and so outcomes tend to be more precise. Not every communication phenomenon can be tested using a classical design, because as we used the example earlier about individuals talking with their parents, the laboratory is not the natural setting that most people talk with their parents. So it's more difficult or almost impossible to study communication in this kind of design. Okay. Other possible limitation is that a researcher, even though they can anticipate conditions or extraneous elements that might affect the design or the outcome, they cannot anticipate every possible influence, because there will probably be something that they did not think about, but it is possible that that might affect. So because of those possibilities, there's also a limitation. And as we said, it may not reflect reality because laboratories pretty artificial, not the real setting that people find themselves in. So based on these limitations, what can we do? So introducing quasi-experiments. Quasi-experiments, we build upon a lot of what classical design is, but one key difference is that independent variable is dependent on natural variations. What that means is that the allocation of the independent variable that researchers are studying is not because of the researcher's assignment, but is naturally assigned. For instance, we cannot control or we cannot assign an individual's sex, male or female. We cannot assign that. It's something that we have no control of. But in quasi-design, we can use what the participant self-identified sex to categorize them differently. So, for example, we may say the independent variable of chocolate effect on a person's sense of happiness. We can compare based on whether chocolate has more effect on men or on women on their sense of feeling happy. So it is a quasi design because it's based on a natural variation as not controlled by the researcher. As we looked at previously, the post-test and pre-test post-test, vectorial, longitudinal designs, they can all be used in quasi-experiments as long as this first element is present, which is natural variation in the independent variable. Okay, few experiments are effective, especially to study communication, because it puts the communication in context. We're studying individuals talking with their parents, for example, in the very setting that they usually find themselves in. Okay, maybe their homes. Okay. Field experiments, researchers can control to some degree independent variable and random assignment, not as closely or as much as they would like, as in the classical design. But they still have some design. The downside to that is actually a benefit because it lets them to observe the communication in the real or natural environment. So the downside of it is also the positive side of it. And it allows the natural environment to influence or to support the conversation or communication that they want to study, allowing the natural unfolding of the interactions to happen. So field experiments or the quasi-experimental design is very useful that way because we are studying participants as they are in their natural environment. Upside to that, we can address real-world problems because we're studying those exact problems in exactly where they are, in the very real settings that we find them in. They happened and based on some natural variation. So based on the natural variation of the independent variable, it's more realistic and therefore is more easily generalizable because it is so close to the environment that the researchers want to study and to support or help. Conditions may not be equal. So for example, we may say the independent variable, say men and women's preference for chocolate and how chocolate affects their sense of happiness. We might end up with groups where there are more individuals of one sex than the other. So when that happens, it's harder to make comparisons because the two groups are not equally sized. They don't have the same amount of people in each of these groups. So conditions are not equal, more difficult to draw conclusive outcomes. Cannot determine cause and effect, reason because of the lack of control or the lower degree of control that researchers have as compared to classical design. So there are downsides to quantitative experiment, but in comparison to classical design, there are some of very strong strengths that researchers might prefer quasi design over the traditional classical design. Participants not randomly assigned conditions. So that's the downside of the descriptive design. And because of these limitations, they are affecting the interpretation of the research findings, can't make conclusive, very strong conclusions. So that's the downside. Online experiments, those are more prevalent these days, and online experiments can be used for all of these designs that we talked about early in today's lecture. We can also use it for field experiments, provided that the online environment is actually the natural environment that the participants are in. Online experiments help us to reach diverse audience, meaning to say that we are not affected by geographical boundaries. We can tap into samples who are much further from us, farther away from us, and that's good because then we have a richer set of participants, and that's a good thing, especially if we want to have a large population, a large sample or a representative sample of the world population. Can also embed audio or video elements. Those might be more challenging to do in the face-to-face or might be a different kind of effect. So, but online experiments allow us to have that possibility. Sampling can be a problem, reason because people who use online environments might be more pertaining to certain demographics. So people who have access to technology or maybe people of certain age groups. So that can be an reason why online experiments may not be as good because the sampling can be an issue. Finally, we look at researchers' effect and procedural biases, and these conditions can be present in any of the design we have talked about today. Biases can be introduced, error can be introduced because of the researchers' interactions or their presence. So for example, let's say we are doing a study on people's thoughts or perceptions about fast food on their ability to exercise. So, given that the consumption of food is important, given that the physical ability to move, maneuver is important, the presence of the researchers, so maybe their age, their sex, their ethnicity, the physical condition, all of these attributes can affect what the participant perceive and affect their ability to perform during the experiments. Researchers might unknowingly say certain things that might influence the responses. So what experiments typically will do is to have very strict instructions that they will give to the participants, so very standard procedures, so always the same thing, so as to minimize those biases and errors. Therefore, we are talking about the detailed procedural steps in order to help us minimize those introduction of unexpected influence on the participants. So with that, we have one final slide to help us think about which of the three types of experimental designs are most appropriate. So first off, are participants randomly assigned to researcher controlled treatment control groups? If the answer is yes, then we are talking about the experimental research design or the classical design. If we say no, the answer is no, then our participants are assigned to treatment and control groups based on some natural attributes. So based on that, we should remember that if the answer is yes, then it should be a quasi-designed. Answer is no, then it will be a descriptive design. Okay, so this is an easy way to help us remember these three types of design and how randomly assigned variables and conditions as well as samples have an impact on which of the designs are used, or to help us label or help us identify the design that's been used. And that concludes chapter 7.